Okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right. 1.358 to the left. Round your answer. The nearest 3 decimal places. So do you have the applet pulled up?
No, I just barely got logged in.
Oh, okay. Just pull it up. Because wouldn't you just put in the z-score and then just take the area?
Yeah.
Wouldn't you just shade the middle?
Combined area under, yeah, I think so. Oh, yeah. It's the combined, so I guess that's the middle, right?
Right, I think so.
1.358.
So if we just shade the middle, yeah, the 0.825, right?
Yeah, that's what I have.
I guess we round.
That's what I have.
0. What would it be?
26.
Okay. Which of the following will have a standard deviation if 9 observations are randomly drawn from a population? Not be determined. The distribution sample means the distribution of the individual observation. Wouldn't it be cannot be determined?
Yeah, I mean, we didn't learn how to do that, or.
Well, it's just like he gave an example in the homework where he was like, well, it's too small, so it can't be determined.
Oh, okay.
So that's my guess, but I don't know. I mean, I guess if we get it wrong, we can just always.
Well, look, I always forget what X bar means. Like the X with the line over it.
Yeah.
Guess I can pause reading, but. What'd you say?
The sample mean.
The distribution of the sample mean? So you're saying it's
The X.
That's what that means.
Oh, okay. So which of the following will have a smaller standard deviation if 9? My guess is that it can't be determined, but I mean, we can always try again if we don't get it. Is that okay with you?
Mm-hmm. Yeah.
Okay. Let's go ahead. Which of the following implies that the spread decreases, the sample size increases? That would be the
large numbers, right?
Was it in the reading?
No, let's see if it's the sample means.
I'm going to say it's either that, the percentage rule, or if it's the central limit theorem, because he talked about both in the video.
Mm-hmm.
So do you have an idea which one it would be?
So a larger spread of sample means.
Let me see.
I guess it's at 60.
Yeah, that's what I would guess too.
Well, when reading the law of large numbers, size in standard deviation of the sample mean will get smaller.
Oh, okay. Let me find it. Yeah, you're right.
Yeah, so I don't, would that.
So I think it would be then.
It's saying if it decreases, it increases.
The sample size, right?
Yeah.
Let's look.
Because the central limit theorem says that if the sample size is large, the sample mean will be normal.
Right.
So is it that the percentage rule? The 68?
Decreases as the sample size increases?
So maybe that would be, let's see.
So that decreases.
maybe.
less of a mean if your sample size increased.
I have no idea on this one.
Yeah, I think it could be the percentage one.
Yeah, I'm gonna put that one down.
Yeah.
Scores on the quantitative portion of the GRE are approximately normally distributed, mu 150.8, the standard deviation. Diane earned a score of 160 on the quantitative portion. What's the z-score corresponding to Diane's score?
So that's easy. We just do the formula.
Mhm.
Here,
Is that
do you have a pen sitting over here, Josh?
Divided by 8.8. So I have
Do you have pen?
1.045.
Did you just do like the regular z-score or the z-score that was in the reading, like with the?
It's like squared, not squared.
The
Square root.
Square root.
Mm-hmm.
Okay.
So
That's what I would think. So I don't know why they put it in the reading if it isn't.
let me do it with the other one. I did the old.
Sorry, I had to grab a pen.
You're good.
Okay.
So with that, I do the square root. What was that formula again?
Of the sample size.
It's this. So it's
Your observation, right? The 160 minus your mean, 150.8, right?
Mm-hmm. Divided by
The standard deviation.
so yeah,
Third.
divided by 8.8,
Yeah.
and then divide that by the square root of what would the square root be? Now I'm stuck. What's n? What's the sample size?
Yeah, so maybe it is just like the regular z-score formula
Yeah,
because we don't have any other info to plug in.
I was like, because we don't have an n.
So 1.045 is what I got with the regular one.
Would we need to put that in the applet?
I think for the next question we do.
What's the probability? So now we put it in the applet, right?
So it's actually probably when a student will score above 160.
Yeah.
So then, Jen, we would just shade it to the right. The one on the right would
Yeah.
be right. And then we look at the area, which I have 0.148.
Is that what you got too?
I didn't hear.
Oh, sorry. So if we put in that z-score that we got, and then we just shade the right side of the applet, it'd be the area that we look at, right?
Okay, and that. Yeah, I think so.
Yeah, I think so.
Okay. So 0.148.
Mhm.
Okay. So what's the z-score corresponding to the sample mean of these students' scores? Round your answer. Okay, so we need to find the mean first,
Yeah.
which is that would be. Do you have it?
I'm looking.
So I got 160.
Okay, I'm almost done. Yep, I got the same thing.
Yeah.
Okay.
Okay, so that's just the mean.
So then
We plug it into what formula?
Where's the z-score?
would our sample be? Would it go all the way back to the?
Oh, yeah.
So we'd have the mean minus 150.8.
That's going to be the same answer.
Oh, yeah.
Do we grab all the information up at the front, at the top?
Yeah, because it says it for the next 4.
Yeah. Yeah, and then we put that over the 8.8, which what'd you get?
Well, I'm confused because the 150.8 was the mean for the information, right?
Oh, yeah.
Oh.
Then we just calculated the mean for those numbers, so we
So,
can't have two means.
Do we have to find x first? 1 minus 160 over 8. We don't have an, well, now we do have an x, which is 1.045.
Yeah, so find 6, and then we can calculate it with the new mean. Jensen, what was the mean that you calculated again?
I have it.
160.
Yeah, so now wouldn't we plug in the 1.045 as the z-score
Times it by
equals x minus 160 over 8.8. Is that right?
Well, corresponding to the sample mean. Because it says here when we're finding mean, we do the formula that was in our textbooks. And then divided by the standard deviation divided by rad n.
So divided by the square root of n then.
But we don't have an n though, do we?
I don't know what our population would be then if that would be the case.
Yeah, that's true.
This is z-score corresponding. So would we just take that same mean and calculate the z-score again, but based off of the 160 rather than the 158? I'm so confused.
So you wouldn't think it was like the same number that we got? Number 6?
For number 6, so like the 1.045.
Yeah, because our mean is 160 and then we subtracted.
We can try it.
Would it be negative?
Why would it be negative?
Well, because the 160 and number 6 is what we are observing, right? And then we have the mean of 150.8.
Mm-hmm.
So in number 8, we have two means, really. Because we found the sample mean of 160, but in the information we're supposed to use, there's already a mean of 150.8. So I think you need to just carry out that.
This?
Yeah, to find out what x is. And then we could complete the problem.
Well, completing x would complete the problem. That makes sense. It's like what I was thinking was take the 1.045. We know that's our z-score.
Mm-hmm.
X minus 160, which is our mean.
Our sample mean, yeah. And then over the 8.8 deviation. So
Okay.
if we go 1.45 times by 8.8, then plus 160.
So if we did that formula,
Mm-hmm.
0.045. That, there we go. Plus 160.
at 169.
169.196, but that's asking us for the z-score corresponding with, wait. Yeah, so the z-score corresponding with.
So now that, well, would this make sense? Now we do 169.196 minus 160.
Because then we'd just be right back at 1.045. So maybe, Jensen, maybe you are right. That they're the exact same numbers.
I say we just move.
Well, I don't-
We'll shoot it through and just see what
yeah,
happens.
let's just
What's the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay, so now we know we're wrong because they can't be the same answer now. Does that make sense? Because it's asking us.
Randomly selected students.
Trying to think.
yeah.
Because now I have no idea where to even start. What's the following information? You want to just like move on to number 10 so we're at least still like moving? Huh?
11 through 15 are kind of the same questions.
Okay. I mean, I have no idea.
For 9.
Yeah.
Yeah, that's weird.
I mean, would you just put in the 1.045 in the applet and just read a certain part of it?
Would we use the other applet that we used?
See, I don't think so, or the instructions would have given us
That other app.
the other applet.
Yeah, that is true. There's like no way, like, I don't.
I just don't feel like the instructions are really clear on.
Yeah.
I'm still trying to look over at 8 and see what exactly it's asking.
Yeah, but these students' means is 160, so it would have to be the same as up here. Wait, is the answer? Oh, okay.
Oh, good. Hmm.
I mean, I say we just move on to 10 and we'll come back to it.
For 10, I think it would be approximately normal. Because don't we have, oh, I guess I got to look up at the information. But if 81 students is our sample, isn't that enough?
I'd say about normal.
Mm-hmm.
Okay, well, that was easy getting all on the back end.
What is the mean distribution?
For all the possible sample sizes that you become from each calculation. Let's see. Do you know how to like do this problem?
No. What does the mean of the distribution of sample means? Okay, so the mean isn't of distribution the same as the sample means?
So the mean is 3.5 and the standard deviation is 0.7. It's left skewed. A random sample of n students will be on. So this is where we're going to run that other. We're going to run, you know, the square rooted one. This is
Okay, for 11.
what's the mean of distribution of the sample means of all possible samples. So we just plug everything in.
I'm trying to look over the preparation assignment. Let's see
I
if
don't
we
think
had.
that's really helping. Like this doesn't really feel like what we did, you know?
Mm-hmm.
I feel like the portion assignment was like more clear than this. Okay, if the sample mean is normally distributed, we can consider the sample mean. So this one, I think we would need to find the z-score and then put it in the applet. Yeah, I have no idea.
Well, just be our mean from the problem.
This would be? So it would be what then? It would be the...
Well, yeah, because mean of distribution is the same as the sample mean. But it's asking what can be drawn from the parent population,
Yeah, that's where I'm getting confused.
but the top is talking about students. Maybe. So that's.
The parent population is
This is
just
just
N.
everybody, right?
Yeah, that's just N.
Oh, okay.
But the reason I'm getting confused is it has us round to 1 decimal place.
Mhm.
I don't know, maybe that's weird.
Oh, but wait, that would, because it's asking about that 3.5, right?
Yeah.
So there's our 1 decimal.
Mhm.
So let's just try 3.5 and we leave it at 1 decimal place.
Okay.
Just literally put in the mean. I guess that makes sense if
That's
you
what
read the
makes
problem,
sense,
like
yeah.
literally. What's the standard deviation of distribution of sample means for all possible samples? What does it say the standard deviation is?
7.
Yeah, because they give us that as well.
Did we just put 0.7? Is that all it says? Yeah.
Now I'm confused
0.7.
because now it's asking about rounding to 3 decimal places. But
I don't know.
Well, I think for this, because it's asking for all possible sample sizes, but we still, because I was thinking maybe we use like that bigger formula,
Yeah.
but like we don't have. Well, maybe we have. I don't know.
So for the next one, at least, didn't he do a problem like this? An example, like in the video.
But the mean GPA be less than 30.
Because don't you just like
What?
certain spots?
I don't know. I can watch the video.
Like he just pulled up the video.
Okay.
I just don't know what number that would correlate with.
Here, I can look it up. I still have the. Be 14 and 15, so it'd be the last two. It'd be the last two.
I think we might just type in the z-score. Maybe I'll check.
Okay, 14 was asking greater than.
Yeah. So this like 14 is greater than, and then it just flip flopped.
So we cannot compute this using an all probability output because the distribution is not normal. That's why it's called an probability output. Only works for normal.
Okay, and number.
A sample size of n equals 36.
So technically, we couldn't find if it was greater than, right? Because you just said it had to be normal, and this is already saying the distribution is left skewed. So we know it's not.
Mm-hmm.
So can we not find number 13 or 14?
Well, he's.
So then I think he said it was 0, right?
I was watching the. Let me look. I was watching the video on it.
Okay, because I think at the end he says it's 0, maybe.
Yeah.
Because if we look at like 14 and 15 specifically, he's got decimal answers for
Hmm. Does it use the and type in the Z score and click?
them. I think he does a formula because
Okay.
we're not able to use the applet because it's not normally distributed.
So this,
Oh, gotcha.
This time our numbers switched just a little bit. This whole section. We're using the same equation.
Okay, so it's the if Jensen, if you have the book pulled up, it's the same formula that's present at the 3 probabilities involving mean.
Okay.
Looks like he's got that x bar plus the
Minus
little mu,
it's mine.
Yeah.
or minus the
Yeah,
mu,
minus.
So in this case,
that other, the O thing divided by the square root of n.
Okay. Because I have, yeah. So that's just the standard deviation. Because the little O divided by square root of n gives us our standard deviation.
Right.
So we have the standard deviation.
So how does he calculate in the greater or less than?
That's what I'm watching.
and you plug that into your calculator, you come out with.
Okay, so we got to get the z-score. Do we have the z-score?
No.
We can calculate it though. So the n is 81.
Yeah.
So what's x and mu standard deviation? And the standard deviation is, so it'd be 3.5 minus 0.7.
No, because your mean's 3.7, your standard deviation's 0.7.
So it'd be flip-flopped.
Because your standard deviation's going to be on the bottom.
Mhm.
Okay, I don't know how to do it then.
I'm going to keep
Standard
watching the video because it looks like he gets a z-score.
Okay, so let's pause so that we can get our z-score, and then that way we can like work with him. So x is what number? The x bar.
That's
What number is that?
x bar is the sample means, right?
Mhm.
Which is,
For that problem, it would be 3.5, right, Jensen, for the sample mean?
Yeah, I think. But then we can't.
we don't have all the
What? Then we have to subtract the mean, but it's the same. Like the mean and the sample mean.
So I guess we need to figure out how to get a sample mean, right?
I think
Yeah.
it's like they're complicated. Okay, so value minus mean.
Can't find the area under there.
Mhm.
I think we're wrong on 11 and 12.
Okay, well, to find the standard deviation, then we should take
We have
like,
deviation, don't we?
yeah. Well, here it says it's the little O divided by the rad n.
Yeah,
Right.
so that would be 0.7 divided by 80. I mean,
Square root of
divided by the square root of 81.
Which is just 9.
so 0.7 divided by 9 is what?
Did you get it?
I got 0.07. How many places are we supposed to round? 3? So 7, 8.
Okay.
So 0.070.
7, 8. 0.078.
I mean, that just solves the bottom. We still need the top half.
Mm-hmm.
We at least have our mean, right? And then we can solve for x. Well, because we need a z-score at least to solve for x.
Okay. I'm super confused.
Yeah, the textbook has nothing really
Yeah.
about like when it's not normal.
Because all the textbook has is if it's a normal distribution.
Mm-hmm. Yeah.
It's like, because if we can't figure out 13, we're going to have a hard time figuring out 14. We can at least do 15.
Okay, what's 15?
So totally, yeah, it's a different. Standard deviation. $26.7. The random sample. Okay, so N is 48.
Mm-hmm.
The sample mean was 177.6. They find the probability that a sample of passengers will have a weight, so we need to find the z-score and then plug it into the applet.
Yeah.
Well, that you just plug into the formula. So the observation is at 185 minus, what's it again? What's this?
That's your mean.
Okay, minus 177.6
6.7.
over 6.7 divided by the square root of 48. So, were you able to get that formula?
Yeah, I'm working on it right now.
We're at 7.4 for the top. The square root. Hey Josh.
Yeah.
Can I have how scary going with it?
Um,
I mean, I should. Want to just put that in? Computer's gonna die if I don't know.
So I think I've got. Did you get 0.1? Or I mean 1.920.
You said 1.92?
Mm-hmm.
920.
No. Let's see, what did you plug into the formula?
So I did 185 minus 177.6
Mm-hmm.
gives you 7.4, right?
Yeah.
And then 26.7 divided by the square root
20,
of,
yeah, 26.7.
divided by the square root of 48 is 3.854, right?
Okay.
And then you divide.
I think my calculations are just off.
What'd you get?
Right. Well, because this is not to round, but I don't have like a scientific calculator.
Yeah, I'm gonna do it the other way and just see if I get the same answer.
Yeah, let me check again.
Do it all together. Break it up.
I just don't know if like it will follow like that. Oh, yeah. The first one.
3.8. Okay, so yeah, that's what I got.
Okay.
1.92
Oh, we plug
is what I have.
I would assume so.
Yeah. Because it says find the probability. So yeah.
Now, what do we shade?
That's
I think I know in the videos he was shading the right side.
So, are we looking for things that are more than our mean? That it is extreme or more extreme?
Yeah. So we got then once you plug it into the applet, 0.0274.
Yeah.
Okay, should I try to put this through and see if see like what we got wrong, if we're even on track for the other question.
Well, let's see. The bottom one only wants you to round to 3 decimal places, so it'd be 0.027.
Mm-hmm. So I tried to put it 3, but then we didn't answer like 3 of them just to see if we're like on the right track.
Jensen, what do you think about the 11 through 14?
Um,
I think we definitely have 13 and
yeah.
12 wrong.
Well, did we ever
I
find?
mean, try for 13 to put in just like the regular mean, the 3.5.
But isn't that what we did for 11?
Yeah, but then because it's asking.
Well, it's asking if
Oh, just kidding.
less than.
Yeah, you're right. Just kidding. Don't do that.
This is so hard.
Do we have a z-score figured out? It doesn't look like it, does it?
So look, I figure we need to find a z-score for this one. We would shade the middle.
And then for
Oh.
this one, we'd shade the last, and then
Mhm.
14 we'd shade the other side.
We just need to find a z-score, but I swear we tried to do that, and it's like an epic failure.
Okay, so the z-score for 13.
Yeah, so for the all the info it gives us,
Mm-hmm.
the standard deviation
Because if we get the but
equals.
What if we find it like the regular way, like how to find a z-score?
Yeah,
okay.
we could do that.
Did we decide it was normal distribution though? Because the applet's not going to help us if it's not.
Because it says it is well known that this distribution is left skewed.
So we'd have
The left. Yeah, because that wouldn't work.
to do it the way the guy does it in the video.
Okay,
Yeah.
Either way, we got to get the z-score.
we don't have enough numbers, I feel like. So the mean. Okay, so I have the standard deviation, the n, and the mean. What I'm missing is the z bar, the value. What is the mean of distribution of the sample means? It's like I just feel like I don't have enough numbers.
Yeah.
We just don't have enough numbers. This is all.
So what is the mean of the distribution from sample means?
I have no idea. I feel like I keep looking at it and I still don't know.
Yeah. Because we need that, like, the value minus the
Yeah, like we're missing the
mean.
If we look at the preparation assignment,
Mm-hmm.
10 through 15, it almost looks like it's the same kind of setup that we're trying to figure out right now.
Okay.
Because in that one, it gives us the n equals,
Mm-hmm.
and then we'd have all the same amount. We'd have the same numbers. So because then if we look at the quiz, 10 through 15 are exactly set up the exact same way, or 10 through 14.
We just
Yeah. But, like, for 13, the answer, what was it asking? It says, can you compute this probability? Oh, it says using the normal applet, and the answer is no.
Mm-hmm.
Right, see with.
It's just the instructions are a little more clear.
I know. I don't know.
Yeah, I genuinely don't know.
I mean, I think definitely after email our professor
Yeah, I'm definitely gonna email her.
and just say, like, we had no idea.
Yeah.
I mean, there is that additional video.
That's
Isn't
the one
there?
I've been watching lesson 7 video tutorial.
Oh, really?
Yeah.
Okay.
It hasn't been helping. I'm tempted just to like try to turn it in to see if we're even on the right track with all the other answers.
Yeah.
Should I try to do that? See if he doesn't solve the problem, he just stops it.
Hmm.
Yeah, I have no idea. I'm just wondering if you got any of the other ones right, you know?
Yeah, I think, I mean, because, I mean, maybe it'll help us.
Yeah, I might just try to turn it in and see.
Okay.
So, okay.
I'm surprised our teacher doesn't like put more videos of her working the problems out.
I was just thinking that today, like, she doesn't really
not really like an active teaching.
I mean, I know she did that review thing for the
Right, we're gonna
test today.
yeah.
Yeah.
So I'm just gonna turn in what we have. Is that okay? And then I'll just have you catch me up. That way we can see like at least like what we're doing right or wrong. So we only got 8 right. We missed number 3 and 4 and 5. We got number 6 right. We got number 7 right. We got number 8 wrong. We didn't answer 9. We got 10 right. We got 11 right, which is putting in the 3.5.
Mhm.
We got 12 wrong, 13, 14, 15 wrong.
Oh man.
Yeah. I don't want to cry. This sucks. Can you catch me up?
Mhm.
Well, we at least can get the multiple choice right.
Yeah, that's true. I mean, we can do the first couple.
We can bump the score from. Okay, so number 1, wasn't it wrong?
6.
No.
That
That was wrong. That one was definitely
That one was
going
wrong.
fast. Go up. Okay, so maybe it's the distribution sample means. This was wrong. I'm going to guess the central limit theorem. 6. That was right.
1.045.
7.
0.148. Okay, wrong.
We left blank. 10. Normal, that was right. This was
3.5.
3.5.
And then the rest was wrong.
Literally the rest of them were wrong.
We still got 15 wrong?
Yeah.
Awesome. That was the one I was feeling about.
So we got number 3 right.
Let me look. Let me see if it lets me go back.
Like if you open a new tab, go and log back into iLearn and go to your quizzes
Uh-huh.
course, you can go in there and see them.
Yeah, okay. This is quiz, what, 7?
Mhm.
Oh, it won't let me. Oh, there we go. Okay, so number 3 was wrong.
What?
Number 4 was wrong. Number 5 is wrong. Number 6 is right.
Okay.
7 is correct.
Okay.
Number 8 is wrong. Number 9 is wrong. Number 10 is right. Number 11 is right. And then the rest of them are wrong. I got a 40%.
Okay. So you have 6 and 7 and 10 and 9, or 10 and 11.
Mm-hmm.
So for 3, I think I don't think we click in the middle.
Yeah,
With the z-score.
wrong place.
Let's see what's the z-score.
And the combined area under the standard normal curve that is to the right and to the left.
So we do on both sides?
Keen.
Maybe. I mean, we can try it again. I mean, there's only so many ways to shade it.
Mm-hmm.
So it could be 0.175.
Okay, for number 3.
Okay.
If I shade both of them, that's what we get.
Okay. And 4 is wrong, so I'm assuming now it's going to be that middle one. The distribution of the sample means. Number 5 was also wrong.
I think 4 is the distribution of sample means.
And number 5 we got wrong. It's not the percentage. So I'm guessing the central limit theorem.
That's the one you talked about in the video. But
We always get another try after.
true.
With that X, they consider this.
We got 6 and 7 right?
Look. 6 is correct. 7 is correct. Look at us on a roll. What was 6? Okay, and then 8 was wrong. That makes literally no sense.
Well, we got 6 and 7 right?
Yeah, 6 and 7 were right.
Okay.
And then 8 and 9 are wrong. And then 10 and 11 are right. And then 12 through 15 wrong. Okay, 160 plus 135 149 plus 153 805. Okay, so it's 100. The mean is 160, which is the same what it gives us.
Mm-hmm. Random sample of 5 students.
Because then I would just assume we minus 150.8 is 9.2.
Red N, or N is the sample size, right?
Mm-hmm.
Okay.
Yeah, I still got 1.045. You compute the mean, wouldn't you? Uh-huh. What else to do? When is the test? Do you know? The test due?
What does it do?
Uh-huh.
I don't know. Friday.
Like, it doesn't look like it's in this.
I didn't see when it closed.
Oh, the exam?
Yeah. Okay, the exam's next week. It ends October 12th. Okay, good to know. Okay,
Are you done?
apparently.
Oh.
What?
I'm confused.
Oh.
On 8, what are we trying to, what's our random value? Like, what are we observing?
The students. Five students?
I don't think so.
Yeah, because I think that's our sample size though.
Because that's our sample size. Yeah.
So it'd be 5 minus 160?
No, because wouldn't the population be 5? So you could easily plug that into N.
Yeah.
Right, like
I
that.
think 5 would be N.
Okay, do you want to try it like that? Do you need a pen? I don't know.
I guess I'm confused what like the X bar and the mu are for this problem.
The X bar is the value.
Mm-hmm.
So what? Because we know what the mean is. It's the 160.
Yeah.
But what's the value?
Is that, let me see.
Yeah, we just need to find whatever the value is. Would this be the value? Not just the score for her score.
Hmm.
Would it be 5 minus 160 divided by 8.8?
It might be because that's our standard deviation. So yeah, maybe let's do 5.
Yeah, like we don't have any better idea.
Because if we put
Mm-hmm.
5 in for X bar,
Mm-hmm.
then we've got a z-score of like negative 17.614.
Mm. Yeah.
No idea.
But then in the video when the z-score was large, let me plug it in. So wouldn't it just be 0?
We can
I
check
don't know.
it.
I'm willing to try it.
Not like we don't have a better plan right now.
We've got like, what, 20 minutes to finish this out?
Oh yeah, you're right.
Good.
Well, and 9 we can't really figure out without the z-score.
Yeah.
To be honest, I'm running out of steam.
Yeah, I know, me too.
I've just looked at everything and I don't know how else we're going to do it.
I know. It's like,
We have every formula we have for every problem.
I know.
Why don't I just be done. See if at least the little fixes we made, like the multiple choice, are right.
Mhm.
And then have her walk us through it.
Be like, and then maybe I could, like, maybe we could see her during, like, her office hours.
Yeah.
Or, you know, I could shoot her an email and, like, include all of us in the email and just say, hey, like, we seriously had a really hard time with this homework. What do we do?
Mhm. I know there's the TA, but I don't think she's available, right?
Yeah, but maybe we could even email her and see if she could help us. Like, I don't know,
Yeah.
maybe she could, reopen it for us or something, you know.
Yeah, definitely.
Do it.
Okay.
Hey, we got 10 now, right? 10 out of 17. So it's not 0 for number 8.
Okay.
And it wasn't central.
Okay, it's not the central limit theorem for number 5, so it might be the law of large numbers or normal distribution.
Yeah. Where's the fun that implies this?
We'll have Jensen try one, and then whatever one's left, we'll
update you. And
Okay. Okay.
I'll try either the law of large numbers. Well, I guess there's only two left to try.
Yeah.
Oh, it's the exact same as the one you have.
So it truly is a 58.
Well, if we get this next one, we might have like at least a D minus.
Woo! How'd you do on the homework last week?
I haven't done it yet.
Oh, okay. The ones
Yeah.
for like week 3.
Like our like for this
Lesson
week
4
or
and
for
5? No, so last week. So this week's lesson 6 and 7, and last week is 4 and 5.
oh. Okay. Well, for question 5, it is the law of large numbers.
It is? Sweet.
Yeah.
So what'd you get percentage wise?
70.59. I got 12 out of 17.
Okay, so wait, what
That's
is
totally a number I can live with. So Jensen, do you want to catch us all up?
Yeah. So for 3, I had 0.175, and it says it's right.
sweet? 4.
The distribution of sample means.
Okay, 5 was the law of large numbers.
Mhm.
6 is 1.045.
Yeah.
7 is 0.148.
Mhm.
8 we got wrong. 9 we got wrong.
Yeah.
10 is normal. 11 is 3.5.
Yep.
And then we didn't answer the rest.
Well, 12 I put 0.078 and got that right.
Where at?
For number 12.
Point.
Why did I put that?
You got it right?
Yeah.
0.07.
I did. Yeah, 0.078. I have no idea why.
Number 12.
But
I hate this. No, I'm not good at math. What's your major?
recreation therapy.
Okay.
Yeah, we don't need any of
No, I'm not math either.
We're sociology majors.
Okay, that's awesome.
Yeah, I just do research. Like, I don't do math.
Okay, so
Yeah.
after 12 being 0.078, did you answer any others?
No.
Okay.
Well, then, if we did 12, we do.
Yeah, because how? What did we do for 12?
I don't think we did 12.
What is the standard deviation of the distribution? That is really weird.
That's inspired, right? I didn't know where you could have gotten that number.
Yeah, maybe. Okay, let me think. What is the distribution of sample means for all possible samples that can be drawn from the parent population? What is the standard deviation?
Shouldn't we be able to do
In
To the applet. I'm gonna rewatch the video just to see where we got that.
I don't know how
Yeah.
we got it.
For less than.
7.
So can we do 13 or what?
If we figure out how we did number 12, we could do number 13.
Oh, I'm gonna cry.
So weird.
Let's do that.
The sad reality is if we get 13, we could get 14.
Okay, so how did we get 0.78?
Okay, so that was the standard okay, I have it on my paper. Let me see. Because I think we just did, because we were trying to figure out the z-score, and so we figured out just the standard deviation by taking this sample size, or because we did rad, or the square root of 81,
Okay.
Right.
which is 9, and then I think
I have this written down. Okay, we did the square root of 81 divided by 0.7, which we got 9. Okay, I have the number 0.078 written down.
yeah, I do too.
I just don't have what we did. Okay, so type in this. Type in 0.7 divided by 9. Give me this.
No. That's how we got it.
That's how we got it. Literally, we just did 0.7 divided by the square root of 81, which is 9. We got 0.78. We just rounded.
Oh, okay.
Okay, so now, so we literally only did the bottom half of the formula
Mhm.
to get that answer.
Yeah, and we can figure out.
If we, because now we have 3.3 is our.
Okay, so now we know n is still 81. 3.3 like the observation.
I would think so.
So we do 3.3 minus what? What's the mean?
Minus 3.5.
Minus 3.5 divided by, what's this? 0.7 divided by the square root of 81. So we know this bottom half is
78.
no. Maybe it's 0.078. So just do 3.3 minus 3.5. 0.078. I don't think it'd be negative. How are you trying to do this one?
I'm not.
Okay.
I'm zoning out. But so are you guys just plugging it into the
Yeah,
how to
I
find
just
the
know if I'm
probability.
putting it in right.
Z-score? Yeah.
I could just plug in
I'm just gonna guess. That's my guess.
point, but it's asking to only round to 3 decimal places, so it'd be 0.005. Okay. Yes, we're gonna.
Okay, so you guys put value minus mean divided by the standard deviation.
Yeah, and we got negative 2.56.
And then if we throw that in the applet and do
We shaded
less
only
than,
the less than.
Uh-huh.
We got 0.052. So now shade greater than.
Okay.
I don't think it's right because greater than is going to be the exact same.
Which shouldn't happen.
Yeah.
Well, anything greater than. Would you shade the middle edge?
Oh, yeah.
I think I just 0.995.
Wait, no, no, no.
Look at the phones. I'm still not gonna do number 15. That's final.
I'm going to submit mine. Is everyone all right with that?
Yeah, I have the answers, Jensen, if you still need them.
Okay. Yeah, I'll just wait to see if they're right.
They're probably not. Whoa.
Whoa.
We got it
You're
right.
Really? Sweet.
We might not fail this class. Okay.
Okay, so 13 is 0.005.
So 13
and
is 0.05?
0.005.
Oh, so 2 zeros after the point?
Yeah.
Uh-huh.
And then
Okay.
0.995.
Okay, you lucky so.
Okay.
Oh,
Because we pulled a B out of that. Incredible.
I'm okay with that for tonight. It's late. We haven't had dinner yet. Okay, sweet. I'm saving my responses, and I am out of here.
Okay.
Sweet. Okay, well, we'll see you on Tuesday.
Thanks, Jason.
Bye.